All right, guys, we are talking today about square roots. We're going to be simplifying radicals, okay? Breaking down. We're always going to simplify our radicals. If there is a perfect square underneath the radical, we've got to break it down. All right, some of you are going to have a little bit of issue with this because it's going to involve a lot of mental math. We don't use our calculators for this, so we're going to have to go through the process of breaking down radicals. Some of you have probably been taught a factor tree, right? You guys familiar with the factor tree? If I have the square root of 20, so you have 20 and then you break it down into 2 and 10 and then you break it down into 2 and 5, yeah? And then you have a pair of 2's that you can bring out, so you would break this down into 2 root 5. Okay, some of you can look at 20 and say, okay, 20 breaks down into 4 times 5, right? Break it down into a perfect square and a non-perfect square. Well, the square root of 4 is 2. It comes out. 5 stays underneath. I sometimes, with bigger numbers, I do like an upside down division. I take 20 and then I go with my prime number. So 2 goes into 20 10 times. 2 goes into 10 5 times. There's my perfect square that I can pull out, something like that. However you guys do it, that's fine. As long as you simplify the radical so there's no perfect squares left underneath. Everybody understand what that means? Okay. If we talk about multiplying square roots or multiplying numbers with square roots, if a number is underneath a radical, you can multiply it with another number underneath a radical. Sometimes I tell the kids a house times a house just gives you a bigger house. Since square root of 2 and square root of 3 are both underneath a radical, you can say that this would become the square root of what? 6. Okay? If you had 2 times the square root of 3, what would that become? 2 square roots of 3. One is outside of a radical, one is inside. So you just write them together. If you were going to say like 2 square root of 3 times 4 square root of 5, what can you multiply together? If you were going to multiply these two together, 2 root 3 times 4 root 5, what would you multiply together? The 2 and the 4, both things on the outside, so 2 times 4 is 8, and then 3 times 5 is what? 15. Square root of 15 goes on the inside. All right, does that make sense? All right, now similarly to how we simplified our exponents and stuff like that, there's different ways that you guys can get to the same answer, which is fine. If you see things a little differently, that's okay. I'm always going to try to take the shortest route, the least amount of work. If I have 2 radicals and I'm dividing them, you can simplify here. You can divide 10 and 5 because they're both underneath a radical. So what would this become? Square root of 2, right? 10 divided by 5. That's fine. Some of you would say, well, don't you have to rationalize the denominator, get rid of the square root of 5? You could do it that way too. You could multiply top and bottom by square root of 5 and then simplify that way. Whichever way you would like to do it, it's totally up to you guys. Do you understand what I mean by that? If I have the square root of 10 over the square root of 5, are you allowed to have a radical and a denominator? No, that's not considered simplified. So if you were to rationalize, we're going to talk about this a little more, but multiply top and bottom by the square root of 5. A house times a house is a bigger house. So you have the square root of 50 over, what's the square root of 5 times the square root of 5? Square root of 25, which is 5. Agreed? Now we can say, okay, can I break down 50 into a perfect square and a non-perfect square? 25 times 2, right? You guys agree? Okay, well, what's the square root of 25? So this is 5 root 2 over 5, and then the 5's cancel. 5 times 10 right here. I just rationalized the denominator. Again, it's a little longer to get to the same answer, but you guys can still arrive at the same answer. Yeah? All right, we're going to just do a bunch of examples, guys. A bunch. If I get through them all, great. If I don't, I'll finish them on a video and make sure that it is posted for you. Tomorrow we're going to do a class kick to practice before our quiz. So if you are going to simplify, that means break down into the smallest possible. So I first think, okay, perfect square and a non-perfect square. What times what gives me 28? 7 and 4, so 4 times 7. Is there a perfect square in there? What is it? Square root of 4 is 2, so this becomes 2 root 7. All right, 48. 8 and 6. Okay, I agree, 8 and 6. Okay, 12 and 4. 24 is not a perfect square. Okay, look, we're going to do this all the ways you guys just said. 12 and 4, is that what you said? What's another one? Anybody? Bigger? Tell me.
16 and 3.
16 and 3. That's where my brain went. All three of these will get to the same answer. Paul's way is going to get us there a little quicker. What is the square root of 16? So 4 goes on the outside, root 3. Can't break down anymore. Now, we come here to 8 and 6, which is fine. Where is there a perfect square? In 8? Okay, so this is really 4 times 2 times 6, correct? So the square root of 4 is 2. And then I have 2 times 6 is 12. Can you break 12 down? To what? 4 and 3, so 4 times 3. What's the square root of 4? So it's going to come out in front. 2 times 2 is what? 4, root 3. This is the same thing there. You want to try to find the biggest perfect square. If you can't, that's okay, just like we did. Break it down into 2 things you know, but you have to keep simplifying and making sure there's no perfect squares left underneath the radical. Inside, hidden in another number. Make sense? Okay. Again, we come here to 2 root 48. Okay, we just have root 48, so we can use what we just learned. This is 2. Break it down into a perfect square and a non-perfect square. The biggest one, I'm going to say 16 and 3. You guys agree? Okay. What's the perfect square in 16? So 4 comes out front. So 2 times 4 is 8, root 3. Questions? All right. 45. 9 and 5. Okay, so 6 is on the outside. Then I have 9 times 5. Perfect. What is the square root of 9? 3 comes out. What's 6 times 3? So 18 square root of 5. Good. Yep.
It's like 3 times 3, but what about the other 3? What happens? That way you just,
What other 3?
it's like you divide 9 by 3 and it's twice, but then 1 comes out for both.
Because you're bringing out a pair. 3 times 3 is 9. The square root of 9 is 3. So you bring out that one pair is what you bring out, in a sense. Like, it's like this. 3 times 5, right? So you're taking out this pair. It comes out in front. It's one pair. Yes, sir?
Like when you're doing that, do you like multiply or like add what you take out of the...
You multiply. What?
Then how do we, on the first one, number 2, like if it's multiplying, then how do you do 2?
For number 2?
Yeah, never mind.
Okay. Sure. All right, numbers are getting a little bigger. As soon as I see anything that ends in 5, I always think money. I don't know why. But as soon as I see 75, how many quarters are in 75? 3, right? So this would be 14 times 25 times 3. Well, what's the square root of 25? So 5 is going to come out in front, and we're going to multiply. What is 14 times 5? So it's 70 square root of 3. All right, 125. What can I break that down into? 25 times 5, 5 times 25, okay. What is the square root of 25? 5, so that comes out in front. 10 times 5 is 50, square root 5. Everybody with? All right, 600. Numbers are getting big, and you're like, no, it's okay. Okay, 300 times 2. All right. What's another way what's a perfect square and a non-perfect square that we could break that into? 100 times 6. Okay. Hannah, 300 times 2 would have worked as well. I'll show you in 1 second. What is the square root of 100? 10. So that comes out in front. So 5 times 10 is 50. And then I have the square root of 6. If we would have gone with 300 times 2. Can I break down 300? To what? 100 times 3 times 2, right? Where's your perfect square? It's in 100. So the 10 would come out. 5 times 10 is 50. And then 3 times 2 is 6. Same thing, right? Yeah? Good deal, good deal. All right, we already did an example like this a little bit ago on our first slide, but anything on the outside, you can multiply on the outside, inside times inside. So what is 5 times 2? 5 times 2 is 10. And then the square root of 3 times the square root of 3 is the square root of what? 9, which the square root of 9 is 3, so this is 30. Do you have to do this step? No, you could just say it's just 3. But I just want to show you. All right, we okay? All righty. Keep on trucking. All right, we're getting a little more advanced here. Again, there's a bunch of different ways you could do this. You can multiply them all together and then break down, but I want to try and do it the simplest way. So I see here that the square root of 5 times the square root of 5 is going to give me the square root of 25, right? Which is what number? 5 times, what is the square root of 9? So 5 times 3 is 15. Good. Again, number 10, a house times a house is just a bigger house, right? You can go ahead and multiply 44 times 11 and then try and break that down. But that number is kind of big. So I'm going to say, okay, 11 is not going to break down. I'm going to leave it here. But I can break down 44 into a perfect square and a non-perfect square. What is it? 4 and 11. Agreed. So this becomes 2 root 11, correct? Times the square root of 11. What can you now multiply together? 11 times 11 is what? 121. What's the square root of 121? 11. So this becomes 2 times 11, which is 22. All right, we multiplied these two square roots together. We got the square root of 121, which simplifies to 11. Just in case you guys are looking. All right, what am I doing in number 12? We're dividing. You can go ahead and rationalize if you want to. Multiply the bottom and the top by the square root of 35, but your numbers get big. I can simplify first. Let's always try to do that. I can divide 7 and 35, correct? How many times does 7 go to 7? Once. And how many times does 7 go into the square root of 35? So this becomes 6 over square root of 5, correct? All right, but what's the problem here? We want to rationalize. We don't want that square root in the denominator. So I'm going to multiply the numerator and the denominator by the square root of 5 to get it out. So my numerator becomes 6 on the outside, square root of 5 on the inside, correct? And then what does my denominator become? Just plain old 5, because the square root of 5 times the square root of 5 is the square root of 25, which is 5. Yes, ma'am.
How come, like, in number 9, when you multiply the square root of 5 times the square root of 5, it still stayed into the square root of 25, whereas with this, the square root went away?
It's not that it becomes square root of 5 times square root of 5 becomes a square root of 25, which then you break it down, it becomes a square just 5. Here, this became the square root of 25, and then it became 5 here. I just didn't write that step.
Oh, okay.
All right, how should I, I skipped number 11, didn't I? We'll go back to it in a second. How should I attempt to start this problem? Okay, we can break down, simplify, good, we can break down. Very good. I looked at this initially and I was like, there's a couple different ways, and I know some of our brains work differently. I immediately said, okay, I can break down 48. I know that 16 and 3 are in there, correct? Everybody with me? And I know that the square root of 16 is 4. So 4 times 5 is 20 square root of 3. That's my numerator, simplified. I looked at it and I said, probably the easiest thing to do would be go ahead and divide my radicals, but those numbers don't divide into each other or simplify together. So that's why I went the route of just simplifying the numerator. So I look at square root of 39. Is there a perfect square and a non-perfect square inside of the square root of 39? No. What should I do? Tell me.
We can say root 3 times root 13.
Square root of 3 times the square root of 13. Do you guys agree? 13 times 3? 39? All right, you could write this. I'm going to write it separately just so you guys can see. Square root of 3 times the square root of 13. What do you now notice? What did we just do? Why did that help us? You can cancel out. I have a root 3 on the top and a root 3 on the bottom. Remember, anything that is exactly the same in a fraction in the numerator and the denominator, you can cross out. So now I am left with 20 over the square root of 13. Is that okay? Why not? Because that square root's in the bottom. What's my last step that I have to do? You got to rationalize that denominator. We got to get rid of that square root of 13. So this becomes 20 root 13 over 13 and 13 is how much? Square root of 169, which becomes what number? Just 13. Now, guys, can I go ahead and just cross these two out? Why not? Because one is the square root and one is the whole number 13. Think about, guys, the square root of 13 is just a nasty decimal. So it's not the same as the whole number 13. If you're going to simplify, it has to be either both of them inside of a radical or both of them on the outside of a radical. Agreed? Let me go back to 11 since I skipped it. Again, I can go ahead and multiply 33 and 11. But what would be easier for me to do? Okay, let's take square root of 11, and then I'm going to break this down into the square root of what? 11 times the square root of 3. Good. So when I multiply these two together, I get the square root of 121, which becomes 11, and then I just have my root 3 hanging out. Sound good? All right, go. Let the fun begin, guys. What's going on here, number 14? We have to distribute. The exact same way you guys would do this with a whole number, you're just going to do it with a radical. Remember, a house times a house is just a bigger house. So I'm going to multiply here, square root of 5 times the square root of 5. I'm going to write the whole thing out. You don't have to. You can just put the whole number 5. But I'm going to say, okay, it's the square root of 25. And then when I multiply a square root times a whole number, what does this become? Negative 2 square root of 5. Perfect. Now, one more thing to simplify. No. What's the square root of 25? 5. So 5 minus 2 root 5. Can I go any further? Can I just say, okay, that's 3 root 5? 5 minus 2 square root of 5. Does that equal 3 root 5? Why not?
Because there's no like radical.
Correct. Guys, think about it. If you are going to combine like terms, right? If I have 3x plus 2, can I add those two together?
No.
Why not? They're not like terms. One has an x and one doesn't, right? So same concept here. They have to have the like term. The last name, quote unquote, has to be the same. If it had a radical 5 with it, absolutely, you could add and subtract it. But you cannot add and subtract if it does not have a like term. A like radical, we'll say. All right, bunch of things going on here. Yes, sir. Sorry.
Is that like because with fantastic you have to multiply it with the subtract and when you say x you cannot multiply? Is that the reason?
No, you can't because these aren't the same. These are two completely different terms. If this had an x on it, then you could say, okay, well, there's 3 of them here and there's 2 of them there, so that gives you 5 of them, 5 x's. But it's like saying you have 3 shoes and 2 Cokes. You can't put that together and say you have 5 Cokes because they're not the same thing. Does that make sense? Okay. All right, guys, there's a lot going on in this problem. And again, some of you are going to go about this different ways than others. I see a whole bunch of whole numbers on the outside that I can multiply together. And then when I look at my radicals, I see a lot of simplifying that could be done, correct? I'm going to simplify each parenthesis separately. So I'm going to keep 3 root 2. There's nothing I can do with that. I'm just going to keep it as 3 root 2. What can I do with the square root of 8? Okay, I can break this down into the square root of 4 times 2, right? Well, what is the square root of 4? 2. So if I bring that out front, I have to multiply it by the number out in front. What's 2 times negative 2? So this becomes negative 4 root 2. Agreed? Okay. And then what can I do with 27? What can I break 27 into? 9 and 3. Okay, good. Well, what's the square root of 9? 3. So then I multiply here, 3 and 3, and I get 9 square root of 3. Agreed? Okay. Now, to me, that was the easiest thing to do. Some of you might want to multiply all the coefficients together, the whole number's out in front, and then simplify radicals, whatever. I'm going to just go about it that way. Yeah, sure, sign out. Say it again?
Is that the answer?
No,
Oh.
I can still, we're just multiplying. So let's multiply. What's 3 times negative 4? Negative 12, okay. What's the square root of 2 times the square root of 2? The square root of 4, which is 2. You guys agree there? Everybody with me? Okay. And then I have 9 root 3. Yes? Okay. Now what?
You have to multiply the negative 12 and 2.
Okay, negative 12 and 2 gives me negative 24 times 9 square root of 3. Can I do anything else?
No. Wait, yes.
You can multiply negative 24 and 9.
We can multiply the negative 24 and the 9, right? Anything that's on the outside, you can multiply together. Now, in my head, I could probably do this, but I'm going to just write it down over here just to make sure I don't make any silly mistakes. There's nothing wrong with writing down simple math problems. What is 9 times 4? What is it? 36. Okay, so carry the 3. 9 times 2? 18. Plus 3 is? So I have negative 216. So your answer here is negative 216 radical 3. Is there anything else I can do there?
How did you get 216?
I just multiplied 24 times 9.
I got 1.
Well, what's 9 times 2? 18, and then add 3. 19, 20, 21.
Oh.
All right. How should I attack this one? Okay. How can we simplify it? We could break up 90 into 9 and 10, right? Okay, you could do that. What's another thing you could do? Does 90 and 6, does 90 go into 6 or does 6 go into 90? So what do we want to do first? Doesn't matter. You guys tell me. How many times does 6 go into 90? 15. So if this becomes a 1, this becomes a 15. So you have 15 over the square root of 15, correct? What else? Do I just leave that? We're going to rationalize. So top and bottom by square root of 15. So this becomes 15 root 15 over 15. What else? I can cancel out those 15s on the outside, and I'm left with just the square root of 15. Now, some of you guys, you saw that problem differently. Some of you said, well, I wanted to start off with 15 square root of 6, so then I can break up 90 into 9 times 10, yeah? Okay, so what is the square root of 9? So this becomes like this. So look, I have 15 root 6 over 3 root 10. You guys with me? Yeah. Okay. The internet's not, but... So we can simplify on the outside, correct? So 15 and 3, this becomes 5. So you have 5 root 6 over the square root of 10. And then now what would I have to do? I got to multiply by the square root of 10 to rationalize. Good. So then you have 5 root 60 over the whole number 10. Now what? You can simplify. This becomes 1. This becomes a 2. So you have square root of 60 over 2. And then we'd have to do what with 60? We'd have to break it down. All right, so again, guys, there's a ton of ways that you can do all these problems. I'm not going to tell you this is the one way to do every single one, because some of you are going to see things differently, and that's okay. But you have to get a method that works for you, and you have to be able to arrive at the answer when you simplify. All right, how is 17 a tad bit different? It's a subtraction. If I said this to you guys, 8x minus 6x, what would you tell me the answer was? 2x. This is the exact same problem. Just instead of x's, we have radicals. You can add and subtract radicals if they have the same radical, the same last name. So I have 8 square roots of 3, and I'm taking 6 of them away. So what does that give me? 2 square roots of 3, right? Easy enough? Alrighty.
If it was 8 square root of 3 and then 6 square root of 4, you couldn't.
Correct. If it was like 8 square root of 3 minus 6 square root of 2. Whoa, crazy looking 2. There's nothing you can do with that. That's like saying 8x minus 6y. That would just be simplified.
So if
Whoop, good question. All right, I love these kinds of problems. I know you guys are like, oh my gosh, she's so weird. This is, to me, this is like a puzzle piece. There's always some sort of clue in this puzzle, right? I see 2 different radicals. What do you think is probably going to happen in this problem? Tell me that, Frank.
You're gonna subtract them.
Okay, probably, more than likely, I'm going to be able to break down the bigger radical and get a common radical that I'm going to be able to combine. So I'm going to use square root of 6 as kind of a guide, all right? I can't break down the square root of 6, but can I break down 24? Okay, so I have negative 2. What can I break down 24 into? A perfect square, non-perfect. 4 times 6. Very good. So as we go and simplify, guys, what's the square root of 4? 2 comes out in front. So now I'm going to multiply. Negative 2 times 2 is negative 4 square root of 6, right? Minus 3 square root of 6. Now what do you notice? They have the same last name, same radical. So if I have negative 4 and I have negative 3, how many totals do I have? Negative 7 square root of 6. Good. Very good. All right. I see lots of stuff here. Let's just go ahead and break down as we go. So I have 3. What am I going to break down 45 into? 9 and 5. Good. And then I have plus 7. Well, what's the square root of 36? I'm just going to say times 6. Not the square root of 6. It's just 6. So now I say, okay, well, the square root of 9 is 3. So I'm going to bring it out in front. We're going to multiply. 3 times 3 is 9. Square root of 5. Plus what? 42. Is there anything else I can do here? No. Why not? Because they're not like terms. If 42 had a radical 5 at the end, then you could. But that is it. Don't be alarmed if you break down and at the end you can't simplify into one concise answer. That's okay. That could definitely possibly happen. All right, again, you want the biggest perfect square, non-perfect square. Give me some combinations of 32. Okay, 4 and 8. Good.
16 and 2.
16 and 2. Good. Anything else?
12 and 3. I'm not on that one.
I'm going to go with 16 and 2. Why am I going to... Could I have done 4 and 8? Absolutely. But why am I going to use 16 and 2? Because it's the bigger one. Good. What about 63? 9 and 7. Agreed? Okay. All right, so let's just simplify. What's the square root of 16? 4. So I'm going to bring that out and multiply. 4 times 3 is 12. Square root of 2. Minus, what's the square root of 9? 3. So bring that out in front. Multiply. So I have 12. Square root of what? 7. Okay, so now I combine those?
No.
Why not? Because they're not the same last name. Good. Good, good, good. Isn't this fun?
No.
All right. Does anybody know what's going to happen in this problem? What's going to cancel? Not everything's going to cancel, but what's going to cancel? The square root of 11, right? What do you notice about these two parentheses? Tell me.
Difference of squares.
Say it again.
Difference of squares.
It's a difference of squares. Good. These are also conjugates of each other. What does that mean?
They're opposites.
Uh-huh. Right? You got it. One has a plus, one has a minus, but they're same whole number 4 and square root of 11. So if we FOIL, you guys remember the FOIL method? First times first. So what's 4 times 4? 16. Then I say first times the outer. What's 4 times negative root 11? Negative 4 root 11. You just stick it together. Okay, good. Now I'm going to multiply the inners. I have plus 4 square root of 11. And then the outers. What's the square root of 11 times negative square root of 11? What is it? It's minus the square root of 121. You're not adding them together, guys. You're multiplying. So what happens here in the middle with these two terms? I have a positive and a negative of the exact same thing. What happens?
Cancel out.
They cancel out. Good. So I have 16 minus, what's the square root of 121? 11. What's 16 minus 11? 5, right? That's a very, very important concept. You guys are going to use multiplying by conjugates a lot in the next 3 years of your math career. We do it all the time in pre-calc. You guys are going to hear that word again. You're going to say, oh, I remember learning that. All right, what does this mean? Do I just take the 2 and I distribute it to here and here? Well, that's what we did the last time. Why is this different? Because what? Say it one more time. Oh, you want to go here too? Okay. Am I allowed to do that? Why? It's good that you know. No, that's good. It's good that you're like, yeah, I know you can't. I'm not sure why, but I know you can't. There's a big reason why you can't. What's it?
Is it because that you do it by the fraction, so it's 2 over 1, so the 1
No. What's in the middle right here, guys? A minus sign, a subtraction. You cannot, if there wasn't a minus sign there, if it was just by itself, we're multiplying, that's fine. But when you have a plus or a minus in between, that changes the game. So what this is saying, whoops, that's not my eraser. Hold on. What this is saying is I have this parenthesis how many times? Twice. This is saying 3 root 7 minus square root of 3 times 3 square root of 7 minus the square root of 3. This says quantity squared. It's like x plus 4, quantity squared. It's not x squared plus 16. It's x plus 4 times x plus 4. So now we're going to FOIL. Just be careful when you do this, guys. Draw arrows if you need to. First times first. We're going to multiply the outsides. What's 3 times 3? 9. Then you multiply the insides. What's square root of 7 times the square root of 7? Square root of 49, which happens to be the number what? I'll write it down just so you guys can see it. We'll simplify in a second. So now I'm going to multiply here. What does this become? First of all, it's negative, and then I have 3. You multiply inside times inside. What's 7 times 3? Okay. Now we multiply here. What does that become? Multiply these two inners, guys. What does this become? 3 root 21. And then the two outers. Negative times a negative is a positive square root of 9. Agreed? Now, some of you will go ahead and simplify this right off the bat. That's fine. You don't have to write it down. I just wrote it out for everybody to see. So as we simplify here, I have 9. What is the square root of 49? 7. I have a negative 3 root 21 and another negative 3 root 21. What does that become? No. If they were opposite signs, they'd cancel. But what's negative 3 and negative 3? So minus 6 root 21 plus, what is the square root of 9? 3. Can I simplify a little more? Okay, 9 times 7 is 63 minus 6 root 21 plus 3. What else? One more thing I can combine. I have a whole number 63 and a whole number positive 3. What's 63 plus 3? 66 minus 6 square root of 21. Can I break down the square root of 21? Well, what are the factors? 1 and 21 and 3 and 7? So it's not going to break down any. Guys, could I have written my answer another way? What's another way I could have written the answer? Tell me.
Maybe factor out the 6.
Okay. You could factor out a 6 and it would be like this. 11 minus square root of 21. Yeah, that's fine. You could also say negative 6 root 21 plus 66. Or, I mean, you just leave it like this. I don't care. But just saying. Like, again, our brains are all, some of us are going to see things differently, and that's totally okay. All right, we okay? What time is this class over? We got 10 minutes. Okay. We're almost done. We're almost done. All right. We don't like square roots where? In the denominator. Okay, we've done this a bunch. I'm going to go through this real quick. If I multiply the top and bottom here by the square root of 2, this becomes 5 on the outside, root 2 on the outside, and then I have the square root of 4, correct? So then this becomes 5 square root of 2 over 2. Agreed? Okay, well, when we have something in our denominator that has more than one term, this is where we have to use the conjugate. When we call it the opposite expression, the grown-up word for that is conjugate. Okay, opposite. So you're always going to take the denominator and multiply by the opposite expression. What would the opposite of 2 plus the square root of 3 be? 2 minus the square root of 3. What you do to the bottom of a fraction, you do where? To the top. We have to be fair. And the reason we do this, guys, is because of that problem we just did. This is the difference of squares. Same two terms, just different signs. What's going to happen when we multiply them together? The radical will cancel out. If you don't flip the sign, your radical won't cancel out. So if you do make that mistake, you should catch it and be like, whoops, it was supposed to cancel out. I did something wrong. So I'm going to just multiply the numerator. Then we'll deal with the denominator. So I have 2 times 2 is 4. And then 2 times negative root 3 is just minus 2 root 3, correct? Everybody agree? All right, now the bottom. What's 2 times 2? 4. What's 2 times negative root 3? Minus 2 square root of 3. What's 2 times square root of 3? Plus 2 root 3. And then what's the square root of 3 times negative square root of 3? Minus the square root of 9. Agreed? Okay, so keep going. So this becomes 4 minus 2 root 3 over, what happens here? That cancels out, which is exactly what we wanted to happen, correct? What right here, guys, is the square root of 9. So this becomes 4 minus 3, agreed? And then what's 4 minus 3? So this simplifies here. Did we achieve what we were trying to achieve by getting the square root out of the denominator? Yes. But you can't just multiply by just the square root. It has to be the opposite expression of the denominator. We're going to do a couple of these real quick. We're almost done. I'm going to skip to 25 and 26, and then I'll do 23 and 24 if we have time. If not, I'll just do it on the video before I upload it. What do I need to multiply the denominator by of 25? In order to get the square root to cancel out, what do I need to multiply? Tell me. 3 minus, very good. 3 minus the square root of 2. And what you do to the bottom of a fraction, you do where? To the top. We got to be fair, guys. So let's go. I'm going to simplify below. What does my numerator become? It's just the same. 3 minus square root of 2. Good. So let's FOIL. 3 times 3 is 9. 3 times negative root 2. Negative 3 square root of 2. Good. Positive 3 times root 2 is plus 3 root 2. And then the square root of 2 and negative square root of 2 is negative square root of 4. What happens here in the middle? Exactly what we wanted to happen. Good. Here, guys, what is the square root of 4? So this is actually minus 2, right? So your answer is 3 minus the square root of 2 over, what's 9 minus 2? Perfect. How many of you like algebra better than geometry? Good answer.
What geometry?
I love algebra. All right, let's do this next one. 26. What am I multiplying by? I want to get rid of the radical in the denominator. I'm fine with a radical in the numerator, but I cannot have one in the denominator. So where do I need to focus? In the denominator. What am I going to multiply? 1 plus. Good. Remember, if you guys make a mistake, right, you make a sign mistake, and you did 1 minus, You would FOIL it out and you would still have a radical in the denominator. So that should set off a bell and a whistle. Be like, whoops, I didn't mean to do that. I got to fix it. All right, come quiz time, guys. There's no questions during the quiz. You can't raise your hand and be like, am I on the right track? I'll let you know when I grade it if you were on the right track or not, all right? So let's multiply. Let's go ahead and work on the numerator first. 3 times 1 is 3. 3 times square root of 2, positive 3 root 2. Root 2 times 1 plus the square root of 2. And then I have square root of 2 times square root of 2 is square root of 4, which is 2, okay? I'm going to go ahead and simplify my numerator here. What can I combine? There's 2 things I can combine. The positive 3 and the positive 2 gives me a 5. Good. And then what can I combine here? I have 3 root 2's and another root 2 gives me how many? 4 root 2's. Good. Now on the bottom, let's see what happens. 1 times 1 is 1. 1 times the square root of 2 is plus root 2. Negative square root of 2 and 1 is minus the square root of 2. And then negative square root of 2 times positive square root of 2 is minus the square root of 4, which is what number? 2. Good. All right, what happens right here, which is what we want to happen all the time? Cancels. And then I'm left with 1 minus 2 is negative 1. You could leave your answer like this. That is fine. Another way you could write it is negative 5 plus 4 root 2, like that. What's another way I could write my answer? Tell me.
You could distribute the negative.
Yep, negative 5 minus 4 square root of 2. Good. Either way, I'm fine with. All right, let's do these 2 real quick. If the bell rings, you guys can get up. But what do I multiply? 23, what do I multiply by? Square root of 3. All right. I would look to see first if 2 and 3 simplify, but they don't. So this gives me 7 square root of 6 over the square root of 9, correct? So which is really 7 root 6 over 3. If you guys want to go from this step here to here, that's fine. You don't have to write the square root of 9. If you know square root of 3 times square root of 3 is just 3, you're fine. I'm just showing everyone. All right, again, what do I multiply here? Do I multiply the top and bottom by 4 minus the square root of 2? No. The only place I'm concerned with a radical is in the denominator. So I'm going to multiply by the square root of 3. So I have 4 square root of 3 plus the square root of 6 over 3. Questions? Can I simplify here and here? Why not? Yep, they gotta have the same. It has to be underneath a radical. If you're gonna divide, they both have to be under a radical or they both have to be outside. All right, good job, guys. Very good job.